This is Lab 5 for Physics 2211, Falling Slinky. So, introduction. The purpose of this lab is to predict and analyze the motion of a slinky falling from rest. Some fundamental physics principles used in the lab include Newton's second law, which is that net force is equal to the change in momentum divided by the change in time, gravitational force, which is force that pulls objects with mass towards each other, tension force, which is pulling force exerted by a rope, chain, or slinky, and etc., and then drag force, which is force acting on an object moving through fluid opposed to motion. And some important formulas used are the velocity update formula and the position update formula. And then the procedure of this lab was to get a video of a slinky falling, upload the video to Tracker and track the motion, use this data to create a computational model, and then graph the observed data and the data from the model and compare. And then the results show that the bottom of the slinky stays stationary until the top meets it, and the top and the bottom of the slinky fall together. And so the observed motion, so our system was the slinky and our surroundings were everything else. So this is the video used. And then for the computational model, so first we set all the initial conditions, including the slinky's mass, the slinky's position, which was at 0 because we set the origin to be at the bottom of the slinky, the slinky's velocity, which is 0 because it starts at rest, and then the proportionality constant, which is just found through a guess and check method. And then the calculation loops, the first one is while the slinky is stationary at the bottom, so we have the gravitational force as the weight, which is the mass times gravity times the force of J, or J hat direction, and then the tension force, which is in the opposite direction of the weight, and balances it out. And then we have the velocity update formula and the position update formula to update those. And then for the next computational model, we have the weight, or the gravitational force as the weight, and we have the drag force to account for that, and then so the force. And then we have, again, the velocity update formula and the position update formula to update both of those. And then for our data, we have our model versus our observed data, and they're fairly close, but you can see some discrepancies, which could be due to human errors in tracking and some other outside forces that weren't accounted for. And then what does this mean? Why did the slinky remain stationary? The tension force continues to act on the bottom of the slinky as the top falls. When the top reaches the bottom gets the information that the tension forces change and falls. And then what would happen if a weight was added to the bottom of the slinky? The slinky would remain stationary at the bottom until the top of the slinky catches up, as long as tension force equals the force of gravity. Thank you for watching.